Hello everybody, so I thought I'd do a video all about singularities since I've been up all night thinking about random stuff, spontaneous symmetry breaking at the beginning of time and all that sort of good stuff. And I thought I'd wax lyrical about singularities for a little bit since it's not so clear in science or in physics specifically whether or not singularities even exist, and it's something of a contentious issue. And I thought I'd add to this rather contentious issue by giving my own sort of take on it. And so the first thing to keep in mind when it comes to singularities, I think, is the Pauli exclusion principle. And the Pauli exclusion principle states that fermions may not exist in the same quantum state as other fermions. And by fermions, I mean particles such as electrons, neutrinos, quarks, and so on. Quarks and leptons, basically. The 12 particles of the Standard Model that sit on the left-hand side of it, whereas bosons, the 4 bosons, or the 5 bosons, including the Higgs boson, if you want to include the Higgs boson, which I wouldn't, but yeah, those can be infinitely in the same quantum state as one another. So when it comes to objects such as black holes and black hole singularities, what would be forming the singularity of a black hole would be an infinite superposition of gamma ray photons, in my opinion, as well as other bosonic particles. So to have a singularity, what you need at the very heart of a black hole is a finite number of photons forming a very dense area in an infinitesimal of volume. So that would be a volume which is, say, oh god, 0.1 times 10 to the minus infinity centimeters cubed, basically, or cubic centimeters. So you have this very, 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 very small grain of somethingness at the bottom of a black hole. And what the Pauli exclusion principle states, of course, is that fermions may not occupy that sort of state. However, I don't think that given the singularity at the beginning of time and the singularity at the heart of black holes, you needn't invoke the Pauli exclusion principle necessarily in dealing with those sorts of areas. Since, yeah, the singularity would only be pertinent to bosons and the behavior of bosons. So, yeah, in light of my most recent thinking, so far as quantum gravity is concerned, I think that singularities may exist. However, they may exist only in the bosonic realm, and that singularities formed of fermions are, of course, not possible because of the Pauli exclusion principle. So, yeah, that's my take on singularities, I think, more or less. So the answer is yes in some cases, but no in other cases. I mean, surely that's what quantum mechanics tends to state about singularities, that they may be formed of bosons, not fermions. Unless, I'm pretty certain people must have thought of this before, surely. If not, I mean, fuck. It's quite a cool thing to have thought anyway, I think. I'm sure many people out there who have a background in physics may disagree with me. I don't know. It'd be nice to have some debate about it. But yeah, so thank you everyone for watching this little video about singularities, and bye bye bye, love you lots.